Hi everyone, welcome to another maths video by Maths with Sarah. So last week I asked a few people on Instagram whether or not they found SURDS or quadratic inequalities harder. Now, quadratic inequalities came out as being the topic that people found hardest, but SURDS was really close. It was like 60-40 or something. So I decided that after that, I did do a video on quadratic inequalities. That's my last video, but I felt like I should also do a SURDS one as well, and rationalizing the denominator one, because I know that's something that a lot of students find really, really difficult. So this is the question that we're going to be tackling today. You've got 6 minus root 8 all over root 2 minus 1, and it's asking you to show that this can be written in the form a plus b root 2, where a and b are integers. This is from a non-calculator paper, so most of the third questions are, because if you had a calculator you could just work out the actual answer, so it would be a bit pointless. It is from very near the back of the paper, so it's question 21 of 23, so definitely looking at grade 9 skills involved in this question. As with all of these videos, I suggest that you pause the video now, have a think about how you would tackle this question, what method you would use. Even if you can't get to the full answer, you can just think about what method you use and come back when you've had a think. Okay, so hopefully you've had a chance to have a look at this question. You've had a chance to pause and have a look at this question. So there's various different ways that you can tackle this question. I am going to start by rationalizing the denominator and then deal with simplifying all the surds and simplifying everything together. But you can simplify everything and then rationalize the denominator. It's entirely up to you. You'll get the same answer both ways. It really doesn't matter. So if we look at this question, we've got 6 minus root 8, and that's all over root 2 minus 1. Now, to do this, to rationalize the denominator, the idea of this is that we don't like having surds on the bottom of the denominator because it's really difficult to deal with. So in order to kind of get rid of this surd on the bottom, we times this whole fraction essentially by 1, but with 1 being the negative of this surd. So exactly the same as this is here, but we just put a negative sign in front of the surd. So as you can see, rather than having root 2 minus 1, we've got minus root 2 minus 1. And then we do exactly the same on the bottom. And if you think, this is just the same as writing 1, because what's on the top is exactly the same as what's on the bottom. But it just means that we can as you'll see in a minute, we can remove this surd from the denominator. Okay, so now comes the slightly more tricky bit. I'm just going to pop both of these in brackets. So hopefully you can see, if we were to just remove this multiply sign, what we've actually got is just one big fraction with 2 brackets on top and on the bottom. Now, obviously, you could cancel these out because they're both the same, but that would be pointless if we literally just put those in order to deal with this surd. So what we're going to do now is multiply this out in exactly the same way you would multiply any pair of 2 brackets. So we start by doing the 6 times minus root 2. So we've got minus 6 root 2. Then we'll do 6 times minus 1, so that would be minus 6. We'll do minus 2 times minus root 8, so minus times a minus equals a plus. And then for now, I'm just going to leave this as root 2 root 8. It's not a good way of writing a surd, like probably best to avoid this. But just for now, I'm going to leave it like this. Then we've got minus 1 times minus root 8. So again, minus times minus is a plus, and I'm just going to end up with plus root 8. So looking a little bit nasty on the top, but we can simplify that all out and it will become much, much easier to deal with. So now if we're looking at the bottom, we're going to do exactly the same. So we're going to have root 2 times minus root 2. So that's going to have minus, and then if you remember, if we times root 2 by root 2, we just end up with what's under the brackets. So that would just be minus, what's under the square root sign, so that would be minus 2. Then we'll do root 2 times minus 1, so we get minus root 2. And then we'll do minus 1 times minus root 2, so that minus times minus is plus, we end up with plus root 2. And you notice that those two will cancel in the end. And then we've got minus 1 times minus 1, so that will give you plus 1. Okay, so if we look at this bottom one to start with, we can see that we've got a minus root 2 and a plus root 2. So we can essentially cancel those out and end up with nothing. And then we've got a minus 2 and a plus 1. So that will add to give you minus 1. Then if we look at the top, we've got some root 8s, we've got some root 2s. It's a bit of a mess really, isn't it? So if we tackle each of these separately and we'll simplify it out. So the minus 6 root 2, there's not a lot we can do with at the moment. Same for the minus 6, at the moment that's just stuck where it is. If we look at the root 2 root 8, now again, there's multiple ways of dealing with this. You can do it in the different ways. So we can do it where, because they're times by each other, that's the same as root 16, which obviously is 4. Alternatively, we can simplify root 8, which we're just about to do for the last one anyway. So if we simplify root 8, and I'll come back to this and show you how to do it. So root 8, remember we can split this up into its different factors, and the aim is to factorize it by a number that is a square number. So in this case, 8 can be made up of root 4 times root 2. And obviously root 4 is the same as just 2. So this will give us 2 root 2. So if we come back to this one, so rather than having that as root 8, because we know that root 8 is the same as 2 root 2, we can do 2 times root 2 times root 2. Now, as we said before, if you do a root 2 times a root 2 or root anything times by itself, then this will just simplify it to make 2. Or whatever is under the square root sign. So that's the same as 2 times 2, which again equals 4. So we've got exactly the same answer again. So if we now go back up to here, we said that we can't really simplify the 6 root 2 at all. We've then got, or the minus 6 at the moment, so we've then got 6 root 2 minus 6. Then we said that this root 2 root 8 can be simplified to just 4. And this can be simplified to 2 root 2. Okay, so we've now got something that is starting to look a little bit more like we can simplify it. So if we look at that, we've got minus 6 root 2 plus 2 root 2. And this is the same. So if we substituted in x, for example, if we had minus 6x, and I would really recommend doing this if you struggle with SURDS. Because I think it just makes it, you're very used to dealing with x's in algebra, so you wouldn't question doing minus 6x plus 2x, which obviously would give you minus 4x, but you might find it more difficult to do exactly the same with SURDS. So I would recommend just substituting in an x. We know that that's going to add to make minus 4x, and then we can just remove the x and pop the root 2 back in. Again, we've got minus 6 plus 4, which is going to give minus 2, and that's all over minus 1. So now the last step is to do the division by minus 1. So if we divide this by minus 1, it's essentially the same as just changing the signs. So it's very easy to divide by minus 1. So instead of having the minus signs here, we can just change them both to positives. So that will give us, not quite in the form they've asked us for, so the form they've asked us for will be 2 plus 4 root 2. So A would be 2 and B would be 4, and we've ended with a root 4. So we've gone from something that looks really quite complicated to actually something that looks relatively simple. And I think most people feel far more comfortable dealing with this equation than they would this fraction at the top that we started with. So hopefully that's run through a number of the different concepts of SURDS. So we've looked at what to do if you've got like a root of its times itself, where you just get the number that was under the square root. We've looked at simplifying SURDS. So for example, if you've got like root 8, you can simplify that to root 4 times root 2, and then simplify the square number. We've looked at how to rationalize the denominator and how to simplify SURDS. So although it really looked like a really complicated question, as long as you remember all the different things, essentially it's very similar to doing an algebra equation. There's no difference in the methods or the principles that you use. If you can apply them to algebra, you can apply them to SURDS. So hopefully that made sense. Hopefully it's helped you a little bit with this SURDS question. Please subscribe to my channel so you get the first look at any new videos. And if you've got any suggestions for topics that you would like to see me cover, then please just drop me a message. Thanks for watching.